bx function. Here are some of the pieces to the tangent function. You don't need to write any of this down. There will be a principal axis at y equals d. A period, a little bit different than sines and cosines. It's going to be pi over b. And then the amplitude will be undefined, different than the sine and cosine. So these two we focused on already in this class. Notice there's a big difference in the graph of a tangent function. I call them like snakes. There's a bunch of snakes going on, or cubics. The period is pi. The amplitude is undefined. You have these domain restrictions or vertical asymptotes at plus or minus pi over 2, plus or minus 3 pi over 2, etc. The range is different. It's all real numbers. All right. So these things I do want you to write down on this slide. The general equation for the parent function y equals a tangent of bx plus c plus d. The shape of the graph looks like a snake. There are asymptotes at left asymptotes of setting this parentheses equal to negative pi over 2 and positive pi over 2. And the period is the distance between two asymptotes. And how you find that is you look at the b and you take pi over b. Be careful, it's not 2 pi over b, it's pi over b. There are vertical translations with these. They can move up or down plus d. So if this is a plus d, it moves up that many units. If it's a minus d, it'll move down that many units. Make sure you pause and write all of those important pieces down. What we're going to do is focus on the parent function. So I want to step backwards a minute and re-look at the unit circle for the tangent function. Remember how we had all these ordered pairs along the unit circle? Here is an ordered pair of 0 degrees, which is over 1 up 2. Then we had another point here of over 0 up 1. Here's a point here of negative 1, 0. Another point here is 0, negative 1. So I just kind of shows some of the angles here of pi over 2, pi, 3 pi over 2, 2 pi. So just a few points here. Where on the unit circle is it undefined? So tangent is referred to as sine over cosine. So if these are your ordered pairs, this is your cosine, this is your sine, this is your cosine, that is your sine, cosine, sine, cosine, sine. When does it become undefined? When I take the sine and I divide it by the cosine, do I get 0, undefined? So let's start with this first point. If I take 0 and I divide it by 1, I get 0. So that's not undefined. Now let's come up here. 1 and I divide it by 0. Yes, that is undefined. So this is a point that is undefined. So at the angle, pi over 2 is undefined. Now let's continue on. Sine over cosine, so 0 over negative 1, we get 0, not undefined. Come over to here. Negative 1 over 0, undefined. So this is another place of 3 pi over 2 that makes it undefined. So that's where your asymptotes are going to be, your restrictions on your domain. So I'm just going to list off here pi over 2, 3 pi over 2. Now, tangents, just like sines and cosine functions, go on forever. So I'm just going to go ahead and put 5 pi over 2, 7 pi over 2. If you wanted to go into the negative angles, you could go negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, negative 7 pi over 2, etc. So again, where asymptotes are going to occur are where they are undefined. So at those green places. Now, we do have asymptotes, left and right asymptotes. So since this is my parent function, there's not a lot of change going on here. This is my parentheses. I'm going to have an asymptote at x equaling negative pi over 2 and x equaling pi over 2. The period is the distance between the two asymptotes. So since my b up here is the number 1, I would say period equals pi over 1, which is pi. So my period is pi. Now add up what is the distance from negative pi over 2 to pi over 2. If I add those two up, I get a distance of pi. So here's what my graph looks like with just one revolution. So here is my x-axis. I just have 0 here. I'm going to go pi over 2 and negative pi over 2. I'm going to create my asymptotes. Now I want to think about some of the points between those asymptotes. So I'm just going to go halfway again to pi over 4 and negative pi over 4. And then I'm going to go up 1 on the y-axis and down 1. If you think back to your unit circle, if I think of this pi over 4 here, if I take the sine over the cosine of that, I get positive 1. So over pi over 4, I get positive 1. When the tangent is 0 degrees, it is 0. So that's this point here. When my tangent is negative pi over 4, I get negative 1. So what I'm getting at is I'm going to start getting these points that look like this. A nice pretty snake. Looks like a cubit. That's one revolution. This period from here to here, the distance is pi. The range is undefined, or doesn't exist. It's everything. It's all real numbers. There's no restrictions on that range. But there is on the domain. There's going to be asymptotes for every distance of pi. So if I wanted to continue another revolution, I could. I would take pi over 2 and add another pi. So I would be at pi here, and then continue on 3 pi over 2. And then I would create my asymptote at 3 pi over 2. And then I would have my center point of 0 at pi and then 0. And then halfway point would be those two places. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. And I go up 1 and down 1. And there's another snake. There is the parent function for a tangent.